Hello everyone, this is Prashant Tiwari and this is my final project submission for CSCI S89B. The topic that I chose was neural machine translation between two languages, and my intent was to try and see how we can translate two languages from one to another. um, so what I chose is Sanskrit, which is an ancient Indian language, and I was attempting to translate text written in Sanskrit to English so that it can be readable and understandable to people. So that is my goal. Now, I first attempted to create a simple encoder decoder model and tried to run, but I realized that it's probably not gonna work. The reason being that Sanskrit is not a Latin-based language, so the tokenizers, encoders, decoders don't work out of the box. So in my research, I stumbled upon a article or a Facebook model that that was machine to machine model that was created with this intent in mind so that somebody or people can train non-English based languages and create a translation out of it. This model by default does not have this capability, so my attempt is to try and see if I can create a model or fine tune this model to um, create a good enough model that can translate from Sanskrit to English. Here's my summary of my approach. Dataset selection. The dataset that I selected for this was a open dataset found on Hugging Face library. This has translation from Sanskrit to English for approximately 75,000 text rows. The other thing that I did was I created a logging in Hugging Face because I also wanted to pull and push data to my own personal repository so that I don't lose the track of it or purpose. So once I have that set up, I did some vectorization on my data, converted to tensors, and utilize the GPUs. And then I decided what should be my appropriate metrics for training loss. And I also utilized Blue Score here. Blue Score is basically used for the translation purpose. It compares the n-gram vectors between the two translations. And basically, the rule of thumb is the closer to one is better. And then I used PyTorch for this whole process. So PyTorch does not have ability to evaluate automatically like Keras. So I did have to create a custom callback to evaluate for each test and validation so that I can plot my graphs and charts nicely. And then at the end of each attempt to train, I am pushing my model to my own personal hub created in Hugging Face as number two, so that I can iteratively keep training this model again and again and get it better. This whole process takes a very long time, so I wanted to keep doing this so that I don't have to start from zero. Now, this is how the dataset looks like. The link is provided above, and this dataset contains translation from ancient Indian text from Sanskrit to English and vice versa. There is a snippet of the dataset as well here. So here's my approach. So model selection and training, I chose Facebook M2M100 model. And basically the code here, what it's doing is this only pulls the base model once. And henceforth, like it trains that model, pushes to my repository. And going forward, it pulls that same model and keeps training it again and again and again so that I am not losing my precious GPU hours. Next is data processing. So I created a neural vectorizer Here, since we are doing text to text processing, my input and output is both text, right? And I need to create encodings, vector encodings of both the text and then decode it as per the language. So the sample is that encoding would be a text in Sanskrit, will convert it into vectors along with padding, and it will return a tensor, PyTorch tensors, and it will truncate more than if there are more than 512 characters. And then the vice versa would be that after the model generation happens, the decoding happens, and it should be able to generate the text in English. This is how my training looks like. I tried for 10 epochs with a batch size of 8. It keeps running out of memory. So for that, I had to use CUDA and accelerators and whatnot. I moved my tensors into batches, moved into GPUs, and utilized Colab's A100, which is the highest capacity that I can get. But even then, it took a very long time to train. Here are some training arguments. So I did a sequence training argument. This is my output directory that I created. Eval strategy was epoch, and save is epoch, and this learning rate. And basically, uh, if I have am using the CUDA, which is more than 8 GPU, it is going to use that. And then the hub model ID is pushed here. So as and when the model finds a better version of it, it will push it to the hub automatically. And here's my training parameter. I created a trainer object, which is again a sequence to sequence with using the above arguments. And neural model is something that I just called my variable in the previous slide. Initialized with tokenized training data and validation data, and then just basically this is how I initialize my trainer, and then next would be trainer.train to keep on training this. This takes a very long time, especially the evaluation part where it's calculating the validation loss in blue score and all that. So I had to only limit myself to 10 epochs with lesser data, but I did attempt to create a like tuned model, and we'll see the results of it too. This is how I did the model evaluation. The trained model is evaluated on a validation set using the Saker Blue matrix. Saker Blue is basically a, from what I have researched, is it's a better trained version of the blue default NLTK Blue, which does some pre-processing and it skips the special characters and whatnot. So it's considered a better than NLTK Blue matrix. And basically, our goal would be to reach closer to one as much as possible. That would we would consider a good translation. So did like created a post-process text. So at the end of each epoch, it will create a prediction and label, and then it will compute the metrics out of it. Um, this is how the evaluation looks like. Sorry, yeah, this is how the evaluation looks like, and this is how the training and validation loss looks like. So as we can see, there is a, like, if this was a scree plot, right about here is the number of epoch I would have chosen for this. Even from looking at the loss, we see that the loss is less. Here it's slightly reducing, but not too much. Uh, More better metrics would be blue metrics, blue score. So if you see here at number 5, I get a better, like closest to 1. So I should take that model at epoch, which and then it starts getting more than 1, which in my opinion, I think that after a while it starts repeating the words, which is why I think it's getting the a more than 1 score in the translation. This is how I do inference. So basically, I pull the latest model from Hub, which would should always be the best model that was pre-trained in the previous training sessions, and this is how I pull it. Say in neural tokenizer, and then pull it, and then basically um, you know um, do the output on the text generation, and then the tokenizer will decode it, and it will print the word. Here are some challenges of it, but before I go there, here are some samples of uh, the text. So this was the original text. This is the ground truth, and we see that translation. It is doing pretty good up till here, and then it starts repeating it. I think I need to train it furthermore and with more tokens and max size limit to improve this, and which is why I think it's getting a more than one blue score. Same here. You see that O chastisizer of foes and then afflictor of foes, which I think it's similar meaning, but then it starts repeating that sequence. So basically, that is the those are the challenges. It's a big model, needs large amount of memory and train further time to train it on the entire data set to come up with a better model. Tensors need to be optimized in a better fashion to keep clearing out the GPU. I kept running in out of memory situations, and I have to like restart my sessions and machines again and again. Max length need to be increased, or basically I need to find a better way to increase the max length so that I can handle longer text to translate. And then evaluation step with this approach is taking a lot of time and need to further optimize it. So this was it. Thank you so much for the opportunity to present.